Now let's talk about an important aspect of the discussion that we have in the agenda for today, which is what we typically call as cluster creation. I want to spend 10 minutes of time on this because one, this is important from your actual application standpoint. This is important from your certification standpoint. And this is at the core of whatever we do in Databricks. Okay. So let me spend some 10 minutes of time because we are a diverse crowd here. And we might be hearing this word called cluster for the very first time. So for example, let's take what we have been doing up until now. For instance, we have a laptop with us in which you have installed your Python and you're doing some data analysis in this Python. Just like we were discussing previously, in order to successfully complete this analysis, you'd require a hard disk. You're supposed to have a CPU, and you're also supposed to have a good RAM, or as we technically call it, memory. These are three essential computing components or computing resources you're supposed to have with you in order to successfully analyze a CSV file. But when we say we are working on cloud, how exactly are we supposed to get these resources? Or in other terms, how do we use this or utilize these resources in Azure Cloud or Azure Databricks that we are currently working? That's exactly where what we say or what we do is that we are going to rent out a virtual machine. And this virtual machine is just like your laptop, but just big in size and big in capacity. Okay. In the most simplest layman terms, if we have to say what exactly is a virtual machine, it's a very big laptop with a lot of RAM, lot of CPU, lot of memory, which is going to be utilized by you or some other company out there in the world. Now, question is that, is one virtual machine enough for us to run our big data workloads on Databricks, for instance? And that's exactly what we have went back and said is that, no, one single server or one single virtual machine is no longer enough. We need to have a distributed computing environment. Okay. So when we say distributed computing environment, it's nothing but a group of virtual machines working together hand in hand in order to successfully accommodate execution of your workloads. So there is virtual machine 1, virtual machine 2, virtual machine 3, virtual machine 4, so on and so forth, depending on the need of your requirements that you have. You will choose number of virtual machines you would typically need to work. So these are also called as nodes from time to time. These are also referred to as nodes from time to time. So between virtual machine and nodes, the teams that we have might use them interchangeably. The terminology we use might be interchangeable. Now, these are each instance or each node here is what we call as virtual machine. But when they're working coherently as a group, then we call this as a cluster. So a group of nodes or group of virtual machines, when working hand in hand, is what we call as cluster. So by default, whenever we say you're supposed to create a cluster, it essentially means that you're having at least 2 virtual machines or 2 nodes as a part of your computing environment. That is the reason why we call that as a cluster, a group of instances working together in the distributed computing environment. Okay, that's the idea. Now, in Databricks, you see, we primarily have 2 types of, I'm saying primarily, the reason is that there is a secondary type, which I'll very quickly introduce you to, but we won't be doing a deep dive. And that's exactly what we'll discuss in the next 10 minutes. But what I'm trying to do is that in clusters that we have in Databricks, we primarily have 2 types. The first type is what we call as interactive clusters. Again, clusters are nothing but the compute that is needed for you to execute your workloads. The first type of clusters is what we call as interactive workloads. And the second type is what we technically call as job clusters. Now, the primary difference between these two lies in its application. Well, let's take an example. I have now got a requirement from my client, which is GlobalMart, the fictitious company we were discussing last discussion, the e-commerce company, which has data being gathered in some database and in some data lake, for instance. Now, you as a data engineer, what you're supposed to do, you're supposed to extract the data from these 2 instances, open a notebook inside Databricks, clean the data, check for all the data quality issues, various data quality issues. Once you have cleaned them, you're supposed to put them in some intermediate data lake location from which you'll again access the data, transform them into business KPIs, transform them into facts that are needed for stakeholders, and then finally put into some data lake or a data warehouse location. This is what we are supposed to build as a data engineer in a specific client project, for example, the ETL pipeline as we call it. This is a sample ETL pipeline. Now, the question is that, would you directly productionize this in the first go? For instance, you own a robot manufacturing company. Would you directly productionize your robot, or you first build a prototype, test it out? Once you feel you're confident that it's very compliant to your needs, only then you productionize. Among these two routes, which one will you pick up? A question to you. Will you directly go ahead and productionize this? Or you first build a prototype, test it out perfectly, very clearly in some developing environment, only then you'll productionize. The idea was that you are never really aware of what are the challenges you might face. What is enough for us, what is not enough for us? Because for everything that you do on cloud, there is a cost associated with it. So what is that optimal trade-off point between cost and performance you're supposed to pick up? How will you figure out all these things? Or how will you figure out whether you require X amount of resources to complete your work? So in order to completely understand these things, or in order to completely develop your code that you're saying here, how are you supposed to clean your data? How are you supposed to transform your data? In order to understand all these things in detail, you're first supposed to have your own development environment. And when you're developing, it is supposed to be interactive. For every execution that you do, you are supposed to see the output, how it might look like. And those are the instances where you'll actually use something called as interactive clusters. Or, as we also call it, most probably an all-purpose cluster. An all-purpose cluster. Now, the reason why I'm saying most probably is that, or most certainly is that, there are several other types of interactive clusters that you have to use, or you're supposed to use when you're in a client deployment. For example, what I'm getting is a streaming source. We talked about clickstream data. I hope all of you remember that. The idea was that when you have a streaming source, when you have real-time data, when you make a transaction, you'll immediately get a call saying that, is it really you who had made a transaction? Or is it someone who is fraudulent, or who is someone that is unknown to you making the transaction? How are you getting these messages, these interactions as soon as you make a transaction? Because your data is being processed in real time. When you have such needs, where you have a very heavy needs for compute, very heavy need for input and output data, then rather than going for all-purpose or general-purpose compute, you might go ahead and use compute-specific or compute-optimized clusters. When you have a lot of intermediary calculations that are supposed to be stored in memory, an example would be a machine learning application. A good example would be a machine learning application where lots of thousands, if not lakhs and millions of computations are stored in your intermediate memory. In such cases, you might go ahead and use something called as memory optimized interactive cluster. And that's exactly what we have seen here a moment ago. When we are looking at our pricing calculator, and when I said, for now, we'll be choosing all-purpose compute, the idea was that there are several other things that you can choose in between in order to run your work. Whether it is supposed to be an all-purpose compute, whether it is supposed to be a memory optimized, whether it is supposed to be a compute optimized, these are specific virtual machines, specific instances meant to do that specific job. So either you go ahead and choose general purpose, in which can be used for all types of development, or you can go ahead and choose the specialized instances with which will actually run the job meant for that specific purpose. So depending on the need, depending on the type of workload, you are supposed to choose, or you're free to choose that specific instance with which the cluster that we have, the group of instances that we have, will be made, where each instance is either all-purpose, which is general purpose, where it is a compute-specific or a memory-specific or memory-optimized instance. Okay. At the same time, one important point to note here is that these interactive clusters that we see here are persistent in nature. What exactly do I mean by persistent in nature? Today, I have worked in developing the pipeline that we have seen here, this entire ETL pipeline that we have seen here. I couldn't complete that in one go because it's a big project for me. This is supposed to be done in next 3 weeks. I obviously couldn't complete this whole thing in one go. So what I'll do, in order to save money, after working on this for 8 hours in one working day, I'll stop my cluster. I'll stop my interactive cluster. Tomorrow morning, if I have to resume my work, I can use the specific cluster that I have used yesterday in order to continue my work. Which means you have the ability to stop and start your clusters to save time and to interactively work and develop your workloads. Okay, that's exactly what I meant by persistent in nature. But on the other hand, what exactly is the purpose of job cluster? Now, you see, as a data engineer, we have developed this entire pipeline. We have run all kinds of testings, and we are very confident this serves my need. This serves the purpose of my client. It satisfies all the requirements. I'm very confident on that. But now we as data engineers are not supposed to intervene every day and execute this pipeline. You can very freely schedule this pipeline and then let it run on the calendar. For example, I want this pipeline to extract the data from my databases and my data lakes 3 times a day, clean the data 3 times a day, process and transform the data, and finally store the metrics, the final KPIs of my data into some data lake location. And all of this execution is supposed to happen 3 times a day. Let's say 10 a.m., 3 p.m., and finally at let's say 11 p.m. These are the 3 times in which client says that or client requests that I want my pipeline to be executed, the ETL pipeline that I have just developed. We are not supposed to intervene and execute this manually. You can very easily schedule this. And when running these kind of applications, or when we are running this scheduled jobs or orchestrated workflows, that is exactly when you are supposed to use job clusters. Now, you might be asking, Soma, why can't you use interactive clusters in this context? What Databricks says or suggests is that cost is one of the most important factors we as data engineers should consider when developing any sort of workloads. And job clusters are meant to be cheaper than interactive clusters, but job clusters, as soon as the execution is done, it will be automatically terminated. And these are not persistent. These are not persistent, which means that once the job has started, once the job has ended, or the pipeline has started, the pipeline has ended, you can no longer access that cluster. There is no way you can access that cluster. The next job that will run at 3 p.m., it will automatically create a new cluster and it will allow you to run. What it also says is that when you request a job cluster creation, it will be up and running in like 1 to 5 seconds. Whereas when you request an interactive cluster creation, it will take more than 8 minutes to 10 minutes for the cluster to be up and running. And there is a cost associated even when you try to get it up and running. So end of the day, when you're supposed to just orchestrate your ETL pipelines, you can freely use the job clusters and save the cost. On the other hand, when it is first time you're developing your ETL pipeline, or there is some issues which you're supposed to fix, there are some bugs that you have identified which you are supposed to fix. During that context, you're supposed to use this all-purpose interactive clusters, fix them, and then push them back to production, during which they actually use the job clusters. That is how we as data engineers manage cost when we are in development environment versus when we are in production. When you're orchestrating the workflows versus when you're developing the code. Okay, so now let's go back to our workspace and see how we can create these clusters.
One question, Soma.
Yes, Ashutosh, please.
Job cluster, it's always scheduled, or can we run it manually also?
No, it is supposed to be scheduled. I'll actually show you that. So you can see my workspace screen, right? The Databricks workspace.
We can see.
Okay, I'll answer that question very quickly. So when you click on job compute, you cannot, there is no create option anywhere on the screen. The reason is that this is only supposed to be associated with your workflow or orchestration. You cannot manually create your job clusters. Does that answer your question? But on the other hand, contrary to that, when you click on all-purpose compute, you can actually see create compute. Perfect. I'll very quickly show compute creation, then we will move on to any questions that you might have. So when you land on your workspace, you're supposed to click on compute on your left blade of the screen. And when you click on compute, by default, you won't be seeing any clusters here. Now, given the restrictions of the environment that we have, please do not create more than 2 clusters at a given time. Because we have a restriction on number of virtual machines that can be created in the Azure account that you have been allocated, which also means that you cannot create, or you're not supposed to create more than 2 active clusters in one go. That's one important point to be noted here. Now, when you go ahead and click on the all-purpose compute, you can click on create compute, which is the first step. So when you see this compute, you see the first thing, there is something called as multi-node and single node. So when creating the cluster, you have the ability to create the cluster with just one server, one VM, or one node. Or when you choose multi-node, that's actually when you're creating distributed environment. Okay, distributed computing environment. So let's go ahead and choose multi-node to get you that experience. Then there is something called as access mode, in which there is single user, shared, and no isolation shared. This is very important from the certification standpoint as well as from your practical application. What exactly is this access mode? Let's come back and very quickly discuss this. For instance, I have me as a part of my project. I have person X, person Y, and person Z also part of the project with whom I'm collaborating and working. Now, question is that when all of us are working towards the same project and same goals, do you think it's wise, or do you think it's efficient when each one of you gets your own clusters? There might be some specific instances where each one of you might need your own clusters or own instances. But most probably what your organizations or administrators suggest is that, why can't you simply use the resources that have been allocated to you as a part of the project? In other words, it's just one cluster that was created for us. And this cluster is supposed to be shared among these 4 people team when you're developing your workload. If that is the case or the context, to save the money, you're assigning or asking the team to use one single cluster and share the resources among the team. That's exactly when we use something called a shared access mode. In other words, when a cluster is created with shared access mode, more than one person can access the cluster in order to execute their own workloads. That's one important point. There is one more aspect called no isolation shared. What exactly does it mean? When I talked about shared mode earlier, for example, Soma, while executing the workload, has run into an issue. There is some module not found issue, for instance. In shared mode, it will not affect the workloads that is being run by X, Y, and Z. At the same time, it will intelligently manage and separate the amount of workload or memory or CPU required for executing Soma's workload, X workload, Y workload, and Z. Contrary to this, when you use no isolation shared, as the name itself suggests, there is no isolation between what Soma is running and what X is running. If Soma runs into an issue, it will also stop all the executions from X, Y, and Z. In other words, what one person in the team does affects the performance of compute for the rest of the team. And that's exactly what we call as no isolation. There is no separation at all when the resources are shared. That is the difference between shared and no isolation shared. Now, there is an important point to note here. What I've shown you is premium workspace. And because of that, you're also able to see the shared workspace or a shared cluster here. Now, tomorrow when you try to create, or today when you try to create standard workspace, you actually can't see shared here because shared workspace is a premium feature. It is not a standard feature. But because I wanted to show you this access mode, I tried creating a premium workspace in which I'm trying to show you this specific access mode. Single user, as the name itself suggests, that cluster can be only accessible by one person in a single time, in one go. Okay. Now you also see the languages at the bottom. What it suggests is that, or as you might be aware, Databricks and Spark are polyglot. What it means is that you can write your code in multiple programming languages. But unfortunately, shared access mode is only supported by PySpark and Spark SQL, and no other languages are supported in I think Scala is something they're just adding, but a while ago, I think 3 months ago, Scala is not even supported in shared workspace. Here you can also see this preview tag, which means it's not yet made available to public. It's still experimental mode. It's still in experimentations mode. This is not yet made available to public. Okay. So whenever you see this preview tag, what it means or what it's supposed to mean is that you should not be using those features or those specific things in production environments because these are not successfully experimented and tested yet. Okay, that's access mode. Just like you have Python 3.10, 3.11, 3.12 versions, you'll also have Databricks runtime versions, 14, 13, 12, so on and so forth, along with which you will also see a tag called LTS. What it means is that wherever you see LTS, Databricks is going to offer you long-term support for it. When we are in academic mode, we'll very easily simply switch from 3.1 version to 3.2, 3.6 to 3.8. But that's not how it's supposed to work in production. Every minor change, as you are well aware, requires heavy testing. And you might not move from one version to another version unless there is an explicit need. And that's exactly why what Databricks says is that if you're planning to use this specific workload for longer time or specific cluster for longer time, choose something that has this LTS tag, which says that they're going to offer you long-term support for this cluster. Any upgrades, any improvements, any enhancements, any performance issues, they're going to keep you supporting for the next 8 years from the date this was released. That is what LTS means. Okay, and this LTS suggests that you use Spark 3.4.1 version, or it uses Spark 3.4.1 version and Scala 2.12 version. That's exactly when I will come back to photon acceleration in a moment. Moving on to your distributed computing, as you are well aware, Spark environment or Spark architecture requires to have one driver node which is master to everything, and a worker node which is supposed to act as executioner for whatever task this driver node is going to give you. When you actually use multi-node, you're supposed to have at least one driver node and one or more than one worker nodes. Okay. Since we are again in academic setup, we really do not need more than one worker node. So please disable auto scaling. What exactly auto scaling means is that today I have a 20 GB workload that I'm working currently, or say 2 GB workload that I'm currently working. 2 GB workload means the data I'm working is not more than 2 GB in size. Okay, but suddenly after 1 year, this has now rapidly increased and expanded to 30 GB. So I no longer can use the same compute capacity I have 1 year ago. Because if I keep on using the same compute capacity, my entire workload will become all of a sudden very slow. It's the same thing that you have with you. When you have 8 GB RAM versus 16 GB RAM, your data operations would tentatively become much faster, right? Something similar. You cannot keep on using the same compute instances or compute capacity. You're supposed to increase. But should you do that manually whenever there is increase in size of the data or the size of the workload? No, you do not have to do that. If there is a size change that is detected, what Databricks automatically says is that I will add one more worker node to your cluster such that your workloads will now become smoother and performance efficient. That's exactly what we mean by auto scaling. It will automatically scale, increase the number of instances that are part of your cluster. Okay, so coming back, what I have is worker type. Please do not have this more than one. Because we are in learning setup, please do not have more than one worker node and one driver node. Because that is going to cost us more. So the cost that you have seen in this pricing calculator is for one server. Sorry, this pricing calculator that you have seen is for one server. Now what we have is two servers in the cluster. So imagine this price being doubled. Okay, please do not worry. We are not going to use this D3V2. I think we are going to, we are going to use T4A, and we are going to use this say for 60 hours or say 80 hours during our entire course of journey in our preparation. So and this is supposed to be, let's say, for 2. So our cost will be typically around $75 to $80 approximately if he uses for 60 to 70 hours, right? So the point being that the more servers that you have as a part of your cluster, the more expensive your workspace is going to become. So kindly ensure that you're using DS3v2 or D4A cluster. I recommend DS3v2, which is still perfectly all right. And do not have more than one worker and one driver as a part of your workspace, sorry, cluster. And please ensure you activate this terminate after and key in the value called 30 minutes. What exactly does it mean? Let's say I started developing my workloads and I want to go for a quick coffee break. Does it mean that your cluster is supposed to run for all the time, even when you're not using it? That's going to cost your organization a whole lot of money. And it's not just you doing that, there's a team sitting and everyone doing that. So what this feature suggests is that if you're not going to use your cluster, or if your cluster is idle for more than 30 minutes, it is automatically going to be stopped or terminated. So please use 30. By default, you'll see 120, but do not do that. Please do it 30. Because we might jump into different meetings. All of us are pretty busy. And if we move into a different call and forget about this cluster being active, the problem is ours are limited budget at labs, and your money is going to be, your credits are going to be consumed. So please keep this either 15 or 30 minutes. If you want to come back and use it, feel free to do so, but please do not have this more than 30. Once you have all these values added, so in order to summarize, you have single user, you can go ahead and use 13.3 LTS. You're not supposed to use photon acceleration. Photon acceleration is something like, yes, Mohit. So max workers, please disable auto scaling, and you can put max worker as 1, not more than that. Okay, because if you have more than one worker node, it means number of servers that we are using are going to increase, and that's going to increase our cost of credit specifically. So please do not have more than one worker and one driver. That makes it total of 2 servers under your cluster. Okay, coming back, have a single user with 13.3 LTS, standard DS3v2, one worker, one driver, and ensure you terminate after 30 minutes. Once you have these settings, please go ahead and create your cluster.